Good morning, guys. I hope you've been enjoying some polynomial long division. We will continue today with that, except we're going to learn a little twist to it. If you didn't like polynomial long division, this twist will help you in the long run. So we're going to focus in on what we call the remainder theorem today. If you don't know what that is, that's okay, but you will learn it by the end of this lesson. So we are still going to be dividing polynomials, but we're going to use this theorem called the remainder theorem to help us be more successful in that. So I want you guys to start with the do now. I give you a polynomial expression to divide, and I'm saying using long division, I want you to divide those terms. So I have it set up on my whiteboard, kind of, I didn't finish, x minus 2. So I gave it to you guys as a ratio here. But I'm going to go ahead and set it up like inside my house. And what goes on the outside? Oh my god, if I didn't change it to a plus sign, I would have just made crazy silly mistakes. So again, another walkthrough. No matter how many terms you have inside your house, whether it's 10, 5, 3, 2, whatever it is, you're just starting with your first term always. And I'm looking on the outside of my house thinking, okay, I have an x here. What do I need to multiply this x by to eliminate that x squared? Well, I have one x here. I need to multiply that by I've changed colors for you guys, another x in order for that to happen. Again, you're distributing this to both of those terms here. So x times x will give me that x squared. And then x times negative 2 will give me a negative 2x. I posted the PowerPoint for you guys yesterday if it helps you to show that I'm distributing this negative to both terms here. So this is really going to become like a negative x squared, and then when I distribute it here, it's going to become a positive. And now those terms will cancel out just like we want, and I'm going to have negative 8x plus 2x, which will give me a negative 6x. And then I'm going to bring down this plus 18. And now I'm thinking, okay, first term here, what do I need to multiply this x by in order to eliminate, cancel out this negative 6x? So I need to multiply that by a negative 6. Why does it have to be negative? You might be thinking. You'll see in 1 second. So when I multiply negative 6 times x, I'm going to have a negative 6x. And then when I multiply negative 6 times negative 2, I will get a positive 12. And the whole reason why I needed that like negative 6 up here is because now when I go to subtract, like always, I have to distribute this negative. That's going to make it a positive, and that's what I need for them to cancel out. And then here, when I distribute this negative, that's going to change that. So now those eliminate completely, and that's really saying to you, in case you can't read that, 18 minus 12 when I distribute that, which will give me a remainder of 6. Some of you guys are still making like silly mistakes when you're expressing your answer with a remainder. I would take my solution, which was x minus 6, that's what I got up there. And then I'm going to, whatever my remainder is, add that. So in this case, it's positive 6 over x minus 2. So my remainder sits in my numerator, and this x minus 2 came from, well, that's always what was in the bottom of my fraction here. And then that's that. That would be like your final answer here with using your long division. But now, in your do now, I'm saying to you guys, I want you to evaluate the numerator at x equals 2. So I'm saying to you pretty much like, hey, I want you to either do f of 2 or like x equals 2, that means the same thing, and I want you to substitute that into your numerator. So instead of writing x squared minus 8x plus 18, I'm now going to write 2 squared minus 8 times 2 plus 18. So all that I did there was substitute in 2 for x. I replaced x with 2. And now you're just going to go straight forward and do the math. 2 raised to the second power, that's going to give me 4. Negative 8 times 2 will give me a negative 16 plus 18. Either way, or you could do a straightforward calculator question, you'll see that you get a remainder of 6. Or, sorry, you get an answer of 6. But what I want you guys to make the connection for is, notice here, when I substituted 2 into my numerator, I got 6. When I did all of that long division here, I got 6. So there is, in fact, a relationship between those two values. So where did x equals 2 come from? I'll give you a hint. It has to do with your denominator there. I basically took x minus 2 and I set that equal to 0 because I know that when I have 0 in my denominator of a fraction, it gives me an error. It's impossible to solve. So I took whatever was in my denominator, set it equal to 0, and then solved. So in this case, I would add 2 to both sides. This is a terrible marker. And I would have x equals 2. That's where that 2 came from. And I know if I substitute 2 in here, it's going to give me 0, which is an error. So that's how we got this 2. And now if I substitute that into my numerator, just like we did over here, it's going to give me the remainder when you do, like, the same remainder that you would get when you do polynomial long division, which is super freaking cool. That whole explanation there is called your remainder theorem. So it will tell you what the remainder is when you are doing long division. I also know, let's make our full circle because we're like right here at this point. I know that since I have a remainder of 6, that means that x minus 2 is not a factor. So that is our full circle. Remember, when you have a remainder of 0, that's when something is a factor. And if you're struggling with that, don't worry, we have plenty of examples to practice. So let's go back to our PDF here. And I want to draw a conclusion there about the general scenario. This is just representing some polynomial. P of x is some polynomial, and x minus a is a linear factor between those values. So I want to draw a relationship between those two remainders. So let's go ahead and do the long division. You guys can get a head start if you need to. I'm going to reseat my whiteboard. Okay, so I have x squared minus 2x minus 25, and I'm dividing that by x minus 7. We should be long division champions at this point, not even pros. So I'm thinking, okay, I need to multiply this x by an x in order to eliminate my x squared there. And I'm going to have x squared minus 7x. Now I know, because again, we are champions, that I need to distribute, I'll show it in the parentheses again, this negative here. And then I'm going to make this into a positive. So those will cancel out completely, and I'm going to be left with a 5x. Next, I'm going to bring down this minus 25. Now I have an x here. Well, what do I need to multiply that by in order to eliminate that 5x? So we should be saying, okay, I need a plus 5 here. 5 times x will give me a 5x. 5 times negative 7 will give me a negative 35. But again, I'm not done because I know that I need to distribute this negative to both terms. So that will cancel out completely. This becomes a nice plus sign, and I will have a remainder of 10. Again, well, if I want to prove my remainder theorem works, I know that I should be getting a remainder of 10. That's what we just saw here. And I also know that x minus 7 is not a factor of this expression here. If I said to you factor this using ABC method, x minus 7 would not be what you get. But if I use remainder theorem, which is what we just learned today, I can take this x minus 7 and set that equal to 0, which simply means that x is equal to 7. If I take this 7 and substitute it in x squared minus 2x minus 25, I should be getting 10 as an answer. So let's go ahead and prove that. I'm going to have 7 squared instead of writing x squared. Then I'm going to have minus 2 times 7 minus 25. And again, this is a straightforward calculator question, or you can do it individually. I know that that's going to give me 49 minus 14 minus 25, which will give me 10. Yep, 10 as your final answer. So that, my friends, is the remainder theorem. You can take the inverse of your linear value here, this x minus 7, you substitute it into your numerator, and then you will always get your remainder. At this point, you guys are good to rock and roll on your own. The next example, I want you to tell me what the remainder will be by using the remainder theorem. When I'm saying prove it, I actually want you to do the lone division here. All right, have fun, enjoy. You must complete these two examples, A and B. You must draw your conclusion here. You must complete plickers and lesson exercise 1 for full credit. Lesson exercise 2 and 3 and 4 will be extra practice if you want to complete, but definitely up to lesson exercise 1. Thank you guys. Bye.